Mercury is basically a big ball of metal surrounded like a tiny bit of rock. And the major question is, why? Why is it like this when the rest of the planets aren't?
Mercury, often just a speck compared to behemoths like Mars or Jupiter, now hides urgent secrets under its surface. Scientists using powerful telescopes have stumbled upon these secrets. They are seeing something moving that they never saw anywhere else. These revelations could lead to crucial missions to reveal a terrifying truth about our universe. We are not alone. Let's reveal the dark shadow that Mercury has kept under wraps. Aliens beneath the surface. This small, quick planet travels around the Sun faster than any other in our solar system, completing its orbit in just 88 Earth days. Historically, our understanding of Mercury was limited. Early astronomers had little more than basic telescopes to study it, and the planet's small size and rapid orbit made it a difficult subject to pin down. It wasn't until space exploration advanced significantly that scientists began to get a clearer picture of Mercury. NASA's missions in the 20th century provided the first detailed images, revealing a landscape marked by craters. These images were just the beginning. Recently, enhanced data from space telescopes have suggested that there may be unusual features beneath Mercury's surface, prompting a flurry of academic interest. This interest has sparked both excitement and a fair bit of skepticism within the scientific community. Some researchers, buoyed by the new data, speculate about groundbreaking findings on Mercury, possibly relating to its geological features or other aspects that were previously unknown. Discussions have begun about more ambitious projects to study Mercury further. These plans aim to explore the planet in greater detail, potentially uncovering new information that could reshape our understanding of the smallest planet in our solar system. There is a sense of anticipation, but also a need for caution, as these plans could lead to more invasive studies that might disrupt the planet's natural state. Amid this renewed focus, it's important to remember the broader context. Every planet in our solar system, including Mercury, has its own unique traits and history, which can provide valuable insights into cosmic processes such as planetary formation and the effects of solar proximity. As scientists propose more in-depth explorations of Mercury, they must balance their enthusiasm for discovery with consideration for the long-term implications of their research. The idea of uncovering new data is exciting, but it's crucial to proceed in a way that respects the inherent value of Mercury's environment. Studying Mercury turns out to be a rather tricky business, akin to trying to take a clear photograph while staring into a bright spotlight. Despite years of careful planning and advanced technology, scientists find themselves stymied by Mercury's proximity to the Sun. The Sun's intense light and heat not only make it hard to see the planet, but also pose a real risk of damaging sensitive equipment like telescopes. Consequently, astronomers can only look at Mercury in short bursts to avoid harming their instruments. Even the powerful James Webb telescope has to steer clear of pointing too closely to Mercury for fear of sun-related damage. The hurdles don't stop at visibility issues. Sending a probe to Mercury is almost like sending it on a kamikaze mission. Any spacecraft that ventures near needs to be heavily armored against the brutal temperatures and the strong pull of the Sun's gravity, or it risks being destroyed. This makes missions to Mercury rare and brief compared to other planetary explorations, which might involve more extended stays. Mercury zips around the Sun at a velocity of 30 meters per second, making it the fastest orbiting planet in our solar system. This incredible speed complicates tracking and studying Mercury and presents daunting challenges for any mission that aims to land on or orbit closely around the planet. Only 2 missions have bravely targeted Mercury so far. NASA's Mariner 10, launched back in 1973, and Messenger, which followed about 31 years later in 2004. These missions represent our main sources of first-hand information about the planet. Mariner 10 was equipped with advanced tools like 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer, essentially making it a mobile science lab tasked with gathering as much information as possible from its quick visits to Mercury. The probe cleverly used Venus's gravitational pull to alter its path towards Mercury, allowing for a series of flybys that revealed the planet's surface for the first time to us Earthlings. The images returned by Mariner 10 unveiled a landscape riddled with craters and strange ridges, much like those found on our Moon. This revealed that Mercury had a rough and heavily cratered exterior, along with a surprisingly strong magnetic field and a larger core than expected, challenging what scientists had previously assumed about its composition. During its second flyby in 1974, Mariner 10 captured views of Mercury's southern polar region, offering new vantage points and data on this difficult-to-study planet. The mission concluded with its final flyby in March of the next year, which provided yet more data but still left scientists wanting more comprehensive information, a desire complicated by the technical and environmental challenges of studying Mercury. To date, most of what we know about Mercury comes from those 2,700 images and scattered instrumental readings from these missions. Impressive, given the circumstances, but also a clear indication of how challenging space exploration can be. Every piece of data from Mercury is hard-won, serving as a small triumph over the vast and inhospitable conditions of our solar system. It highlights how our pursuit of knowledge about our planetary neighbors is often constrained by the realities of technology and the harsh environment of space. Thus, studying Mercury serves not just to quench our thirst for knowledge, but also as a reminder of the inherent difficulties of probing the cosmos. Each new finding is a step forward, yet it underscores the slow and laborious nature of uncovering the complexities of planets like Mercury. Next, we explore what happened after Mariner 10 and how its legacy led to new missions, exploring the enigmatic terrain. When the Mariner 10 spacecraft ran out of gas in 1975, its mission ended, leaving it to drift silently in space. This marked the end of an era, but also set the stage for its successor, NASA's Messenger, which took to the skies 30 years later. Unlike Mariner 10, which merely flew by, Messenger had a more ambitious goal. It was to enter into orbit around Mercury. This mission was designed to do much more than take pictures. It aimed to dive deep into understanding Mercury's atmosphere, its chemical makeup, and its physical features. Armed with the latest scientific equipment, Messenger was tasked with uncovering the detailed characteristics of Mercury. NASA's goal was clear: to gather a wealth of data that would offer insights far beyond the superficial layers of the planet. This probe was equipped to explore every aspect of Mercury, from its magnetic field to the geological and physical structure of its core. The mission was not just about capturing images, it was about comprehensively mapping and understanding Mercury. During its mission, Messenger made 3 crucial orbits around Mercury and took an impressive 200,000 photographs. These were not just ordinary images, they captured detailed views of Mercury, including areas never seen before during previous missions. The data revealed intriguing details. For instance, there were unusually high levels of calcium and magnesium on Mercury's darker side. This discovery likely raised questions about what processes contribute to such concentrations. Additionally, the planet's magnetic field was found to be unusually strong in the northern areas, which was unusual compared to other planets. As NASA analyzed the data, it became clear that Mercury's unique magnetic field was due to its internal structure and how it had formed. On most planets like Earth, magnetic fields are generated by the movement of liquid iron in the core. As the planet rotates, this liquid iron moves and generates electrical currents, which in turn create a magnetic field. However, Mercury's internal structure is different, leading to different magnetic behavior. The findings from the Messenger mission are significant because they offer a deeper understanding of Mercury. This is not just about gathering data for the sake of it. This knowledge helps scientists understand how planets form and behave. It challenges previous assumptions and provides new insights that could be applicable to other celestial bodies. This narrative of Mercury's exploration is a story of human curiosity and technological advancement. The journey from Mariner 10 to Messenger shows our progress in space exploration technology and our deepening understanding of the solar system. Each piece of data Messenger sent back to Earth not only added to our knowledge of Mercury, but also helped us see our own planet in a new light. By studying Mercury, we learn more about the universe and our place within it, highlighting how interconnected and complex the cosmos really is. As we continue to analyze and understand the information gathered by Messenger, we build on the legacy of past missions. Each discovery adds to a growing body of knowledge that informs future explorations. The story of Messenger and Mercury is a testament to the enduring human spirit to explore, understand, and constantly push the boundaries of what is known. Hauer from the University of California, Los Angeles, discovered something unusual about Mercury that has puzzled many scientists. Usually, in planets like Earth, iron changes from liquid to solid at the innermost part of the core. However, in Mercury, this change happens at the outer boundary of the core, which is not what was expected. This finding challenges the way we thought terrestrial planets behaved and suggests that Mercury has a unique way of doing things. In explaining this phenomenon, Hauer compared it to a snowstorm where snow forms at every level of the cloud, not just the top or bottom. This means that on Mercury, iron might be forming solids throughout the fluid that surrounds the core, affecting the planet's magnetic field in unusual ways. This discovery has important implications for understanding how magnetic fields are created on different planets, as it shows that the same ingredients can produce very different results under different conditions. Further analysis, backed by data from NASA's Messenger mission, supports Hauer's findings. It seems that despite having similar elements like sulfur and iron in their cores, Earth and Mercury behave very differently. This raises interesting questions about the ways magnetic fields can form on planets, suggesting that what we learned from Earth might not apply universally. But Mercury's unusual characteristics don't stop at its core. The surface of Mercury experiences extreme temperature variations that are baffling as well. During the day, temperatures can reach a boiling 430 degrees C, and at night, they drop to a freezing minus 170 degrees Celsius. These drastic changes are due to Mercury's almost non-existent atmosphere. Unlike Earth, which has a thick atmosphere that helps regulate temperature, Mercury has only a thin exosphere made up of atoms knocked off the surface by impacts from space rocks. This thin exosphere does very little to protect the planet from temperature extremes or to retain any heat. It's so insubstantial that it's barely there at all, contributing to the extreme conditions found on the planet's surface. This aspect of Mercury is another factor that sets it apart from Earth and challenges the assumptions we have about planetary atmospheres and their effects on surface conditions. Such insights into Mercury's conditions provide a clearer picture of just how diverse planets can be, even within our own solar system. Each planet operates according to its own set of rules, influenced by its unique composition and environmental conditions. The study of Mercury invites us to expand our understanding and consider that the behavior of other planets might also differ from Earth in significant ways. Considering all these points, we're reminded of the complexity of space and the planets within it. Mercury serves as a case study for the unexpected, teaching us that planetary science is full of surprises that defy our standard models. As we continue to explore and study other celestial bodies, we are likely to encounter more examples that challenge our existing knowledge and push the boundaries of what we know about the universe. Each new discovery adds depth to our understanding and prompts us to keep questioning and exploring the vast unknowns of space. With Messenger's journey over, We now dive into Mercury's extreme conditions and surprises. A year shorter than a day. Mercury attracts scientists mainly because it's extremely hot. This intense heat prevents any kind of stable atmosphere from forming, as gases likely evaporate into space before they can accumulate. Mercury doesn't have a protective atmospheric layer, resulting in one side facing extreme heat from direct sunlight, while the opposite side remains dark and cold. What stands out about Mercury is its peculiar day and year lengths. One full rotation of Mercury on its axis, which counts as a day, takes 176 Earth days. Meanwhile, a Mercurian year, the time it takes for the planet to orbit the Sun, is only 88 Earth days. This oddity leads to one side of the planet being scorched by the Sun for long periods, while the other side experiences an extended night. The idea that any form of typical Earth-like life could endure such conditions seems far-fetched. Despite this, the harsh environment of Mercury has sparked a lot of discussion and speculation among the scientific community. With its magnetic field and a composition that includes rocky terrain, Mercury shares some characteristics with Earth, although the similarities largely end there. The thought that Mercury could be a home to life challenges our understanding of biology, given its severe climate. Interestingly, Mercury's surface is peppered with many impact craters, much like our Moon. These craters are often the subject of speculation, as each new discovery on the planet's surface leads to more hypotheses about what might be possible there. This has led some to wonder about potential life forms that could exist, perhaps adapted to extreme conditions, living in the cooler, shadowed craters, or utilizing minerals from the rocky soil. Theories about life on Mercury often require stretching the imagination to consider types of life that are vastly different from those on Earth. Could there be organisms that thrive on radiation, or life forms that exist without water? Such questions push the boundaries of current scientific thinking and delve into more speculative biology. This continuous interest in Mercury is not just about finding life, but also about understanding the limits of planetary environments where life might exist. Every theory, no matter how imaginative, helps scientists think about life's potential resilience and adaptability under conditions that are unlike anything we experience on Earth. Moreover, the harsh conditions on Mercury serve as a reminder of the diverse and extreme nature of planetary environments. While it's tempting to think of other planets as places where hidden forms of life might be discovered, the reality often highlights the uniqueness and fragility of Earth's biosphere. Mercury, therefore, serves more as a subject for theoretical exploration rather than a serious contender for colonization or life-supporting potential. Its value lies in what it can teach us about planetary science, the formation of solar systems, and the conditions under which life might struggle to exist. The continued interest in this small, fiery planet shows our desire to understand the cosmos and our place within it, exploring not just where life currently exists, but where it might conceivably take hold. The idea that Mercury is covered in craters from alien spacecraft is certainly interesting, but it's more likely something out of a science fiction novel than actual science. Some craters on Mercury have unusual shapes like domes, which have led some people to think they might be evidence of alien activity. However, there is no solid evidence to back up these claims of extraterrestrial bases or alien work on the planet. Despite the lack of proof, a number of people are quick to suggest that Mercury might be a hotspot for aliens. This theory got a boost when NASA's Messenger probe crashed into Mercury on April 30th, 2015, creating a big crater. This event has been used to support the idea that other, perhaps alien spacecraft could have also crashed there, leaving similar marks. Today, Mercury's surface is full of craters, cracks, ridges, and signs of old volcanic activity, almost like it's been a battleground for both natural and possibly unnatural events. Recent findings have also added to the speculation. Scientists have found ice at the bottom of some craters at Mercury's poles, areas that are permanently in shadow and very cold. This discovery has led some people to imagine that there might be forms of life, similar to the extremophiles on Earth, that thrive in very harsh environments, living in this icy part of Mercury. Adding to the intrigue, a new study from a planetary research institute has suggested that conditions around Mercury's North Pole could be right for life forms that like extreme conditions. These life forms would be hidden below the surface, away from the harsh conditions on Mercury's exterior. The study used detailed maps created from data gathered by the Messenger spacecraft, and it has opened up new ideas about what might be possible on Mercury. However, without direct proof, these ideas remain just that, ideas. They rely heavily on interpreting available data in very imaginative ways, often ignoring simpler explanations that involve normal geological and cosmic processes. These fascinating but unfounded stories capture our imagination, making us wonder about what lies beyond our current understanding. Yet they often overlook the importance of sticking to scientific evidence and what can actually be observed and measured. In reality, while the ice-covered and crater-filled surface of Mercury might indeed be hiding interesting geological processes, jumping to conclusions about aliens and extraterrestrial activities is a big leap. It goes beyond healthy scientific skepticism, which relies on solid evidence and observable phenomena rather than intriguing but unsupported theories. The excitement of such theories shows our love for exploring the unknown, but it also highlights the need to keep our speculations grounded in reality. The study of planets like Mercury should focus on expanding our knowledge through careful observation and analysis, avoiding the distraction of overly imaginative theories not supported by evidence. Scientists recently discovered salt glaciers on Mercury that contain volatile compounds, which they believe could support some form of biological life. Despite the planet's extreme conditions and its close distance to the Sun, some researchers are optimistic that if we dig deep enough, we might find alien life forms or simple biological organisms. This possibility was highlighted by the significant findings of NASA's Messenger probe, which meticulously mapped Mercury's surface, showing its craters and basins and giving scientists a wealth of data to analyze. Our discoveries on Mercury challenge what we thought we knew about planets, a small planet with too many intense secrets. The Messenger probe did more than just create a map. It also analyzed the chemical composition of Mercury's surface. The planet is composed mostly of 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. But it also has a surprisingly high amount of volatile elements like sulfur and a surprisingly low amount of iron. This composition is unusual because most planets in our solar system have more iron, particularly in their cores. The difference in Mercury's composition caused quite a stir among scientists, as it doesn't follow the common patterns observed in other planets. Adding to the ongoing discussions, scientists have also noticed a strange dusty ring around Mercury. This was unexpected because Mercury is quite small, and traditionally, only much larger planets like Jupiter and Saturn have been observed to have rings. Jupiter's rings are faint and were only discovered in 1979, while Saturn's prominent rings are made up of many ice and rock particles that are visible from Earth. These rings are believed to have formed early in the history of our solar system and are maintained by the planet's strong gravitational pull, something Mercury is not known for. The discovery of Mercury's ring raises a lot of questions. Is this ring a temporary feature, or does it suggest something new about how planetary rings can form? Could it indicate that there was more to Mercury's past that we don't yet understand? These findings challenge the usual theories about how planets and their rings are formed and suggest that there may be exceptions to these rules that need to be explored. This ongoing investigation into Mercury's unique characteristics highlights the fact that there is still so much we do not know about our solar system. Every new piece of data provides valuable insights, but also uncovers more questions that need answers. It reminds us that our current theories might be just partial explanations, and that more detailed studies could alter our understanding of planetary science. Scientists are compelled to continue studying Mercury, driven by its unusual characteristics and the new data provided by the MESSENGER probe. Each discovery on Mercury not only adds to our knowledge, but also challenges our assumptions and encourages more rigorous scrutiny of what we think we know. Mercury, with its unusual orbit and its new ring, serves as both a challenge and an invitation to the scientific community to delve deeper, ask more questions, and perhaps revise some of the long-held views in planetary science. Saturn and Jupiter are like the giants of our solar system, their massive size allowing them to collect many moons and pieces of debris, forming impressive ring systems. Saturn's rings are especially famous, sparkling brilliantly. While Jupiter might not be as well known for its rings, it compensates with its huge number of moons, a whopping 95. These giants make Earth look tiny by comparison, highlighting their ability to pull in surrounding cosmic matter with their strong gravitational forces. Then there's tiny Mercury, seemingly punching above its weight class in the planetary system. It's surprising to find that Mercury, the smallest planet in our solar system and lacking a thick atmosphere, boasts its own ring system. This ring isn't made up of large chunks of ice or rock like Saturn's, but rather a fine dust spread across a wide area, around 9 million miles across. The general consensus among scientists is that this dust could be leftovers from meteorites that have hit Mercury in the past. This theory seems reasonable because Mercury, with its exposed position near the Sun, gets hit a lot by meteorites. Dr. Peter from NASA and his team believe that these frequent meteorite impacts could throw up enough dust to form the ring visible today. This idea is quite straightforward. Without any thick atmosphere to protect it, Mercury is more likely to collect debris from such constant bombardments. Most scientists agree and suggest that meteors and other space debris have continuously struck Mercury, shaping its surface. These impacts have also contributed to Mercury's relatively thin outer shell, which is only about 250 miles thick, unlike Earth's thicker crust. With a large metallic core making up about 85% of its diameter, Mercury shows signs of having gone through some rough cosmic events, likely losing much of its outer layers in the process. This explanation, while it fits well with what we know about how planets and their rings form, might seem a bit too neat. It assumes that all there is to Mercury's ring is the outcome of simple impacts, overlooking potentially more complex dynamics at play. These dynamics might tell us more about how such a small planet can hold onto this dust despite its weak gravity. While the idea that meteor impacts could create a ring around Mercury is the leading theory, it does simplify the situation. It suggests that the most visible and straightforward evidence is all there is to the story. However, the formation and maintenance of planetary rings, especially around a small planet like Mercury, might involve more subtle and intricate interactions in space that we have yet to fully understand. Recognizing the limits of our current explanations is important as it keeps us open to discovering new aspects of planetary science. This ongoing investigation into Mercury's ring, therefore, is not just about adding a piece to the cosmic puzzle, but about appreciating the complexity of these celestial mechanics, which might be more involved than they initially appear. Initially, Mercury was left as the tiny planet we see today, built on assumptions that require further investigation by NASA and other space agencies. Much of what we assume about Mercury needs more in-depth exploration. Yet some might question whether this is just a routine part of space exploration. The achievements of the Mariner 10 and Messenger missions were significant, although they might appear minor compared to other cosmic discoveries. These missions courageously faced severe solar radiation and other space challenges to give humanity a brief glimpse of a planet once considered unreachable. In contrast to more spectacular discoveries in the universe, these efforts might seem less impressive. Nonetheless, the extreme conditions these probes endured to gather data from Mercury warrant the praise they receive. As we dig deeper into Mercury's secrets, we prepare for new adventures and findings. Mercury's hidden depths, beneath the craters. NASA used advanced technologies for these missions, some of which were considered ahead of their time. Now, with even more sophisticated technology available, plans are in motion to explore Mercury more thoroughly and uncover what lies beneath its scarred and pockmarked surface. What has intrigued scientists most about Mercury is not just its battered exterior, but the rough, unusual characteristics that hint at more stories beneath its craters. Mercury's surface, filled with over 500 craters, presents a harsh and unwelcoming landscape. This rugged terrain might lead someone to think there is much more waiting to be discovered beneath its rough exterior. Such a landscape might encourage people to imagine all sorts of dramatic discoveries waiting to be made. However, with the infinite expanse of space filled with countless wonders, one might wonder why so much focus is placed on this small, seemingly less important member of our solar system. While the scientific community continues to praise these missions for their resilience and groundbreaking encounters with harsh space elements, a more critical perspective might see them as just another step in the long, ongoing journey of human curiosity. Important, yes, but perhaps not as groundbreaking as we might hope. As efforts continue to explore deeper into the planet, we must consider whether the findings from Mercury will truly transform our understanding of the cosmos or simply add minor details to our extensive astronomical knowledge. Exploring Mercury deeper could reveal more about its composition and history, helping scientists understand not just Mercury, but other celestial bodies with similar features. Each crater on Mercury's surface could be a clue to past events in the solar system, such as collisions with asteroids and comets. This information could help us learn more about the dynamics of our solar system and even about the conditions necessary for life on other planets. As technology advances, the possibility of sending more sophisticated probes or even manned missions to Mercury could become a reality. These future missions could provide even more detailed information about the planet's atmosphere, geological history, and potential for supporting life in harsh conditions. This continued exploration might also lead to better technology on Earth, as the innovations developed for space travel often find applications in other fields. However, despite these potential benefits, one must consider the cost and resources required for such missions. Is the investment in exploring a small, barren planet like Mercury justified, or could these resources be better used elsewhere? This is a debate among policymakers, scientists, and the public as space exploration continues to balance scientific curiosity with practical considerations. Mercury, though often overlooked, is marked by numerous craters across its surface. Some are relatively small, around 9 miles wide and 7 miles deep, while the largest span nearly a kilometer in diameter. These features, the scars from countless impacts by space debris, hint at the solar system's violent history. The exploration of Mercury requires advanced technology, far beyond what previous missions like Mariner and Messenger could offer. Enter BepiColombo, a sophisticated spacecraft developed through a partnership between the European Space Agency and JAXA. Launched on October 10, 2018, this craft is equipped with the latest in planetary research tools, featuring both a planetary orbiter to study the surface and a magnetospheric orbiter to examine Mercury's magnetic field. BepiColombo's journey is a long one, with its arrival at Mercury scheduled for 2025. The wait gives rise to both anticipation and a fair share of anxiety. What if this mission, armed with its cutting-edge technology, fails to live up to expectations? Space exploration's history is fraught with spectacular triumphs and disheartening setbacks. As Mercury begins to attract more attention compared to its planetary siblings, the importance of BepiColombo's mission becomes ever clearer. This isn't just another routine space mission. It's an ambitious attempt to gather comprehensive data from a planet we know surprisingly little about. The stakes are incredibly high, and the outcome of this mission could significantly influence our understanding of the solar system. The spacecraft aims to explore all aspects of Mercury, from its dense metal core to the peculiarities of its thin atmosphere. This thorough investigation could provide unprecedented insights into Mercury's composition and evolution, offering clues about the early solar system. While we wait for Bepi Colombo to reach its destination, the space community holds its breath. The success of this mission could lead to major advancements in our knowledge, potentially positioning Mercury as a key subject in future cosmic studies. Alternatively, a failure could be a major setback, reminding us of the immense challenges that lie in understanding our universe. As 2025 approaches, excitement and skepticism mingle. Will Bepi Colombo unlock new levels of understanding, or will it encounter unforeseen challenges that hinder its progress? This mission could either open new avenues for discovery or serve as a harsh lesson in the limitations of current technology. What are your thoughts on the potential risks and rewards of the Bepi Colombo mission to Mercury? Like, comment, and subscribe to join the discussion and stay updated.